It's a pretty nice classroom. I've got surround sound speakers. I've got the projector that projects like straight down.
Uh-huh.
I've got the TV over there, and then the shades are really cool because I can raise them automatically.
Nice. Automatic
So
shades.
look
And
outside, or if it's a little bit bright inside, the sun's coming in, I can look down the shade.
yeah, so make it easier for you. And with a push of a button, that's nice.
Push the button. Nice and easy.
It's a beautiful view right there too.
So we've got this is really, if you really want to get a nice view, because of this back window. So this is, of course, this is where I teach. This is the teaching area. This is like the lab.
This is the front.
Formal lessons there. And this is my lab benches back here. The kids will come back here and do various labs. I have a lab bench up front, so like for demonstration and stuff, like you guys will be seeing today. In the back here.
Go on.
You've got the fume hoods back here. Okay?
Got the vent hoods
The vent hoods.
for the very dangerous labs.
Yeah, so for like the things that have like noxious gases and things like that, I can do them in here in the fume hoods. That's my coworker, Mr. Mills. He's back there working pretty hard, so I'm gonna leave him alone.
Okay.
Got plenty of glassware, all kinds of glassware, all the glassware you possibly want. To see.
Beakers, funnels. Oh wow, cylinders. You got all kinds of stuff in here.
Amazing stuff. It's really nice.
This is a great setup. Eye wash in case any of your kids decide to get a little
Yeah.
beside themselves.
And then this view back here is actually really nice.
This is beautiful.
So if I was to stay here longer, I'd probably try to figure out some way to use this back space more often. But for now, we use it for like kids who need like a quiet space to work, or if they need to come back and have a private place to work or something like that. It's really nice. It's really nice to look at.
It's
I enjoy
beautiful.
it.
I want to get started.
You want to get started? Let's get started then.
I should have brought the little camera holder so I could film it and like participate and listen in. Look at this beautiful periodic table here. Guys, take a seat in class. Pick a desk. Right up front. That's nice. Caleb, you want to take it? Oh, probably right over here. Mr. Reynolds has all you need all set up. He's ready to go. He's going to teach class. This is the first time they've sat in class since what? March of last year? Almost a year.
Do we have one of those things in the car
What things?
to hold their phone?
The car cup holder. I don't know if it would do it. Yeah. What's this?
Maybe hook it up to that.
Will that do it?
Really get it right.
Oh, look at that. Clever.
If you want to even have it like around the case, should hold it.
That might would do it. Yeah. It's holding yours. You guys ready for some action?
Yeah.
All right.
So,
Do you want to try that or no?
Well, I'm
I have
just
a few
gonna.
things queued up for today, so I'm gonna start on some of the more simple stuff. While that's getting started, I'm actually gonna start this one off, and this is going to be a balloon that we're going to actually blow up. And so,
We tried that one, but it didn't actually work.
well, I promise you this one's gonna work. So this is zinc metal.
Zinc metal.
This is zinc metal, okay? So zinc metal is weird shaped metal,
Okay,
okay?
let's get a nice close up.
Okay, it's got zinc metal. So put that inside of the Erlenmeyer flask.
Erlenmeyer flask. Is that what we
Erlenmeyer
call
flask.
that? And anybody want to guess why do we call it an Erlenmeyer flask?
Nope.
Professor Julius, can you tell us why do we call that Erlenmeyer flask?
Probably because some guy named Erlenmeyer discovered the flask.
That's exactly right. That's exactly right.
Invented it.
Mr. Erlenmeyer figured out the way to make that flask.
He sure did. And then this right here is called a Bushner funnel.
A Bushner funnel.
Because Mr. Bushner.
Mr. Bushnell. Oh
that
yeah,
is-
we got like a little pipette, a place
So-
for your pipes to go there.
So
Okay.
this is a 3 molar hydrochloric acid solution, right? So this is pretty strong.
That's the real deal right
but it's
there.
okay. because-
Check it out, you guys. Check it out.
So what I'm going to do is I'm going to put some hydrochloric acid in there
With the zinc metal.
with the zinc metal.
We've got two substances going in, guys. And what we're doing here, is this a chemical reaction or a physical change?
Okay.
Mmm.
Not quite.
Let's check it out.
Reaction.
I think it's a reaction.
So as that progresses, you'll see this balloon start to blow up after a while. So it's going to take a little while. So that's why I'm going to
Takes a while.
But while we're waiting for that,
Moving on, Jen.
Mm-hmm.
There you go.
so we'll do a quick experiment here. Okay.
Okay.
Oh, you see the balloon starting to blow up
Here's
already?
the balloon. Is that so cool, you guys?
All right. So this is copper 2 chloride solution. It's a nice blue liquid, really pretty color. Okay. And this is a very household item.
What's that, guys?
A wrap Reynolds?
This is Reynolds wrap, aluminum foil. Okay. So I'll take a little bit of aluminum foil, crumble it up nice and loosely, and I'll throw it into the copper 2 chloride solution. You hear that?
Keep our eyes on it.
You can hear it.
You can hear it.
That's because I have really good hearing.
You see that thing? You see it changing?
You see it changing, Jenny?
Mm-hmm.
You see it?
It's turning
Pick it up on the camera.
green.
Ooh.
Jen, you want to get closer?
And just for a little bit more of an educational piece to it.
Educational piece, here it is. I love it.
It's blowing up. See it, Caleb?
Okay.
Can you explain what that means?
Yes, I will.
And our balloon is steadily blowing.
It's your scientific formula there.
Yes, I haven't seen that in about 25 years.
All right, and it's actually, so Caleb, come here.
Go, walk over.
All right, so you feel the glass. So take your hand right there.
Let's feel
You
it.
feel that?
Feel warm? All right, it feels nice and warm. You feel it? Want to feel it too, Jay?
Come walk over and feel.
Right here, you feel right.
Wet and warm.
It feels nice and warm, doesn't it?
It feels hot.
It feels hot.
Feels
right?
hot. Let's
Feels
check
hot.
it out.
It's not like scalding.
Ooh, yes, nice and warm.
Nice and warm on the sides.
What do you think's causing that warmth?
The wrap. The Reynolds.
Yeah, the reaction.
So
It's making a reaction.
that's because there's an extra product produced as a result of this reaction called heat.
How about that? Heat.
So what's happening is when you throw the aluminum, right, so the aluminum foil into the copper 2 chloride solution, the blue stuff, a single replacement reaction takes place, okay? And this reddish orange material that you see in here now is actually copper. The
Nice.
Copper came from the solution. So
Nice.
actually, the aluminum
Broke it
went
apart.
into the solution, and the copper came out.
I love
This
it.
is a type of chemical separation technique that can be used, and it actually is used in industry. So if you wanted to collect copper, which copper's not a very expensive metal, so you probably wouldn't do it very often. This balloon's getting nice and big, nice and big.
Hmm.
You know how big that's going to get?
Not much. If I let it go for a while, it can get kind of big.
Yeah, I didn't know if you were going to.
Yeah, no, I'll let it get a little big. It's not gonna pop.
Oh.
It doesn't have enough force going in
Oh.
here, so you can see there's plenty of space left in the balloon. This is a bigger balloon. This one you can like blow up to be like party size. So we want to make sure that it's not one of the small ones because you definitely want it to pop on you by itself. We don't need to worry about that just yet. Okay.
I want a volcano.
A volcano.
Wait, just
Well,
wait.
hang on. We got
Now,
some
if
pre.
we may need to come back for another lesson because I gotta go to the store and get some yeast. I thought we had some downstairs.
Okay.
We can do it, and the yeast is what you really want to use with some baking, with some hydrogen peroxide, some yeast, and then food coloring, and that's what elephant toothpaste is.
Ooh.
Peroxide and yeast.
I think we watched a video of that once.
Yeah, you probably have seen the video.
Yeah.
This is vinegar.
Vinegar. We've used that before.
So you probably seen this before. We got vinegar and baking soda. Okay. Have you used it to put out a fire before?
Never used to put out a fire. Wow.
So add it nice and slow. You can see it start to fizz up, start to fizz up, start to fizz up. Now, this reaction has one of the products of this reaction, one of the things that are created as a result of these two things mixing together is carbon dioxide.
Yes.
Okay? Carbon dioxide is what you breathe out. So
We
that's
breathe
carbon
out.
dioxide.
Yeah.
Carbon dioxide is more dense than air. Now, what does that mean? That means that if you perform a chemical reaction and carbon dioxide is produced as a result, it will stay inside the container.
Interesting.
And so I have here, yes, ma'am.
Did you use this for making cola?
For cola, carbon dioxide. For like Coca-Cola, Sprite. Very good, actually they do. So what they do is they take carbon dioxide, right? And they have the liquid, so like the soda, before it actually gets the carbon dioxide in it, is flat. So it actually starts out as flat soda. And they chill it down to make it really, 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 really cold. And then they pump the carbon dioxide in and then seal it up. And so when you open the bottle, when you open a can or you open up like the soda bottle, and you hear that tss, that's the carbon dioxide actually foaming and fizzing out of the solution. Good question. Very good question.
She's an excellent scientist, of course.
She's working on it. She gets it from her mother.
Oh, can you tell us what that little gadget is?
So this
To make fire. To make fire.
Let's listen to what it is, guys.
is a Bunsen burner.
A Bunsen burner.
Okay? Bunsen burners are kind of like analogous with the idea of chemistry. Okay, everybody, whenever you think chemistry, you think Bunsen burner. Okay? And so a Bunsen burner, this right here is flint. Flint can be used to start fires in the wilderness. But here in class, we have gas that is pumped in from outside. And I simply started off with a little bit of a spark. And then you got fire. And so what I'm going to do is I'm going to light, very gently, just light that up. Okay? Okay, so everybody keep your eyes on the match. And if this works properly like I think it should, I should be able to put out that fire with nothing but what's inside of this container.
How about that? Oh.
Guess that?
Ooh.
Guess that?
Did you see it blow it out?
Okay, let's try it again. Let's try it one more time. Just
One
for y'all.
more
Yeah, just the
time.
gas that blew it out. Just the
Yeah,
gas.
that's just the dense carbon dioxide that snuffed that thing out so fast. Oh, that's a cool experiment, Professor Reynolds.
So this is actually something you can do at home.
Yeah, I know. You
It's
know,
not
I'm
dangerous
thinking.
at all. You could just use. You wouldn't use a Bunsen burner. You would use like this.
Right, right.
You could even do this like if you wanted to put out candles naturally, like at your house. If you wanted to do that whole process. Now, if you look real close, you maybe even be able to see it falling out of there.
Just like that.
When it
And then you
smothers
can
it.
see it kind of resting, even the smoke is forcing the
Suffocates.
smoke.
It forces
Yeah.
the smoke down because
Forces the
it's more
smoke
dense
down.
than the smoke, and so it pushes
Yeah.
everything else down.
Yeah, it pushes it all down. That's fascinating.
And so the balloon has gotten really, really big. Okay?
Check it out.
Okay. Now, before I actually take that off, I'm gonna write that equation down on the board too.
What's
So,
up, buddy?
The Lost in Oz movie, it has
this
elements
one,
in it.
I'm actually gonna have
Think
them
so.
back up to probably the third row seat.
Come on, guys. Let's back up for this one.
Come on, guys.
Got one more experiment, or not, I don't know if it's one more, but this next experiment.
Right here.
You know, the whoosh bottle is probably gonna be the last one. The
Okay, the whoosh bottle.
whoosh bottle is a pretty interesting one. I'm gonna grab one of these sticks.
Does it leave around the classroom?
Okay. Right now is hydrogen gas.
Ooh,
Okay?
yes,
Hydrogen gas is highly flammable.
highly.
Okay? Now, it would be dangerous, really, really dangerous, if I were to put oxygen gas in here as well. Because then you've got the perfect ratio for an explosion. But this one just has hydrogen gas inside of it. And so the ratio won't be perfect because all the oxygen is outside of it. So there's only hydrogen in here, so the ratio is not perfect where it needs to be for the perfect idea for an explosion. But that does not mean that we can't get a really good boom out of this thing. Okay. So I set it up there so that way I can step back over here. Okay. So
It's gonna be loud.
what's about to happen here is it's going to be a combustion reaction.
A combustion
Okay?
reaction.
Combustion reaction, okay? Combustion reactions are how cars work. Okay? And so we're going to combine, we're going to pretty much use the fire on the end of the stick as a starter for that combustion reaction. So here we go. Okay, if you can, please cover your ears. 3, 2, 1.
Woo! Wow! That was amazing.
Big fireball.
Right, so it's a big fireball. Now, if I were to combine oxygen in there as well, it would get even bigger. That's something you got to take outside.
Wow.
So it gets to be
Yeah,
really, really,
let's
really
do
big.
that.
No, you're too dangerous.
No.
Yeah, that one's a little bit too dangerous. I even had to do that in my class, where I even have all the safety tools I need. I still hesitate to do that outright. Okay. So, on the topic of combustion reactions, we can simulate sort of the inside of an engine by using one of these.
Cool.
Okay, something that everybody's got around their house. Actually, if you drink, you've got ethyl alcohol at your house, you can do this at your house. I wouldn't recommend it.
Ethyl alcohol is the same as vodka. There we go.
Same kind of stuff you put in drinking alcohol.
Okay.
What you do is you just introduce a little bit of alcohol in there.
Julius,
You have a question?
Yes, sir.
what do you use the TV for?
The TV I use mainly for diagrams, different types of things I want to show the students. Like if I have a periodic table, like see how that one's all over there, I'll bring up another one on the screen for the kids over here.
See it really is.
Or if I'm just showing them something, or if I'm working through a problem, I may have it on the board for the TV too. It's mainly just educational. Hey, but it does get cable, so I do watch TV in here. Like one year, I think the first year I was here, I had a Super Bowl party with pizza and stuff like that. And so the idea is just to coat the inside of this thing with some ethyl alcohol. I'm probably gonna give it a little bit more.
Does that evaporate?
It evaporates very quickly, so ethyl alcohol is highly volatile, which means it'll evaporate very, very fast, very, very rapidly, but it also makes it very, very flammable, which is why we're only using a little bit, we're coating the insides of it, okay? Now, if I can get this to work just right, it's really, really, really interesting, the way it goes. Okay? So,
Let's
once
listen.
again,
The Bunsen burner goes on again.
You gonna move the, I see you got the other alcohol.
This will make a lots of gas.
okay?
Yep,
Let's see if we got
this
this to
will
work.
make lots
Check.
of
Uh-oh.
Now,
Back up, bud. Holy moly! Woo-wee.
Again!
Holy moly!
Right, so that one, and if you feel it, right, if you feel it,
Feel it, guys.
feel it, hot, right? Warm.
Ooh, that's very
If you
warm.
actually look at the bottom, you see that liquid at the bottom?
Uh-huh.
It's brown.
That's water, but it's got, of course,
Yellow.
that's got it's got some trace elements in it though. So it's got some other stuff in it, some residual ethyl alcohol maybe that didn't evaporate. The majority of that is water. Because the products of every combustion reaction are always carbon dioxide and water.
How about
Okay.
that?
Okay, so if you perform a combustion reaction, water is going to be produced. But in your car, in your engine, of course, the water that's produced, because it's in such a hot environment, evaporates almost instantly. But in this, because the heat leaves and is able to be released, the water stays behind. There's actually some carbon dioxide. Okay?
Cool.
All right. So
Yeah.
that's all. Now I was asking you guys if you had made it to town yet because I was gonna say pick up some gummy bears. We can do that next time.
Yeah.
Okay, yeah, so we'll do gummy bears, elephant toothpaste next time, and then some dry ice fun.
Yeah. So then, now the dry ice one I can do really quickly. It's just literally just to put the dry ice in some water.
Let's check it out. You guys wanna see it?
Okay,
Let's do it.
so while we do that, actually I'll give you a tour of the rest of the building.
Let's do it.